Welcome back, everyone, with Fun with WebGL 2.0. This time around, I want to try something different. I'm going to show you some of, like a demo of what we're working on today. Get into some code, then we'll do some changes and get into a better demo. So today's lesson, we're continuing off with the last couple of lessons where we're dealing with Bezier curves. Last lesson, we created splines. And the editor tool to control it. So today's lesson is to animate on the path. So right now, as you can see, you don't see the path because I didn't really create the initialization routine. But as long as the moment I start moving something, you'll see the debug lines, so you can see what the curve looks like. And as you can see, we already have something that animates, and we're going to look at the code in a little bit and how this works. Now, the beauty of it is that this thing animates in real time. So I can actually change the curve all I want. And the animation will just keep going in real time. So there we go. This is great stuff right here. So now that you know what we're working on today, we're working on animating on our Bezier spline curve. Let's go look at the code and how to do it the way we want it. So one of the first things we're going to do is we're going to go into our debug class and fix our draw function, because I think 2 lessons ago we changed how the renderer works. Now we need to bind the vertex array in our draw functions. Since this thing is not extending the renderer class by it's not extending the renderable class, we need to go back and change its draw function. At some point, I really should do that so we don't have to go back to any custom functions, but I digress. So that's just one thing. So this way we can use the debug lines. We need the debug lines to see these red lines over here. And what those red lines represent is the direction vector that each sample point is going. So that kind of helps us determine something that we'll look through. Because one of the things we're going to do later is fix the cube so it animates looking in the direction it's going. So these red lines dictate what the direction vector is. So once we know which direction each sample is going, we can then rotate the cube to be looking in that direction. So it, like right now, it kind of just a plain old cube without any rotation, just animating. So we wanted to animate it where it's more realistic. We'll do that the second part of the video. So that's why we need debug to be working correctly again. So that's number 1. So we're going to go to core, and we're going to do a couple of small changes. One changes is to our vec3 class, and I added this OR condition. So this way I can pass in an array. So if I pass in a vec3 or just any array in general, I want to initialize it using those values. So next new thing, normalized. Normalized now has an out parameter, and anything related to the out parameter has been changed. So these 5 lines are coded new. Moving on to the next. I want to speed this around. I want to make this a long video explaining every little bit. This stuff, I just want to really show you the small changes we need to do to the engine to really get this done. So next, we got some new functions. We got the dot product and the cross product. We need those to help us determine rotation based on the direction that you're looking at. So that's why those there. Very useful functions. Now we're going into our quaternion class. I added in these new get functions and set functions, because I write these things in a funny way. So get and set for all 4 parameters, properties, I guess they're called, to the quaternion, because remember it's an array of 4. Next, added a normalized function to the Quintorian. It's very similar to the Vec3. So we might need to normalize. Let's not, we'll come back to this later. What else? That's it for this, but we'll come back to this later, so you guys can do it later. Now in our spline, so where do we begin for our spline? All right, so our spline, we're going to have the get position, which we already had the get position, but I upgraded it where with all this fun math. And what it does is take the entire spline and reduce it to a 0 and 1 position, because normally that's how the cubic Bezier point algorithm works. You take the curve of 4 points and you tell it somewhere between 0 and 1 time position that you want the position at. But since we have a bunch of curves tied in together, we need to expand that. So I wrote a lot of comments to sort of really understand the math, because it's very simple. It's really just division, and the division works great as long as you do not go at 1 or greater. So as long as you're under 1, it works perfectly. Yeah, so it's that's all it is. This tells us, these 4 lines of code basically tells us which curve are we currently trying to access, and then converts the time to the time that's for that curve. So it's not really complicated, and the comments here explains everything better than me just reading it. So that's position. And next function we have that's new is get direction. Follows the same math to figure out which curve that we're currently working on the spline, and then here, and it uses the cubic sorry, it's really late, it's like midnight. It uses a new static class, which just this static class, which is also down here, is what gives us these red lines. These are the directional. So anytime you see like the equations for Bezier and you want to find the direction, what's the algorithm, what's the mathematics, it's always called a derivative. So it's always the Bezier derivative. But like I said, that derivative gives you the direction value, direction vector. If you normalize it, it's not the normal, because I was reading that the normal is something else. So even though it is the normal, it's the direction you're going to, it's called the tangent curve, which I guess it makes sense because it is kind of tangent to the position that it's in. So this would be the tangent, and then the actual normal will be going in this direction. So it's kind of like going away from it at like a 90 degree. What I've read, it's like if you want to get the normal, you just take your tangent and then you, I guess, rotate it by 90 degrees or 45 degrees or something like that, and do something else to it, and that becomes 90. I haven't have a need to get the normal yet, so I haven't really got into it I haven't read too much into it. But this one is the most important because we need this to help us determine which direction to look at while we're moving through the curve. So that's the direction function that we need, so we can get it at any point on the spline. And then we have the actual algorithm. You know, you just pause, type it out, or get it from GitHub, which would be easier because trying to get this just right if you're typing it, copying from the screen might be a bit much. All right, what else we got? All right, what class is this? So the Spline Editor. So the Spline Editor update data mesh function. we're putting our direction. We're setting up a variable for our direction. Then inside our loop, we're going to reset our debug lines, because this is where we're going to be drawing our direction lines. It'll be here. This part is what actually, we get the direction, we normalize it, multiply it by 3. That's how long I want the lines to be. So if I really want to change it up, I can just do times 8. And if I were to refresh and see, our direction value is now a lot longer. So that just shows you what we're doing. So like I said, we're normalizing, multiplying, then we're adding the position, and then we add that direction value, and position is where the point actually is, and that creates our line. And then at the very end, we update our debug lines, which then pushes all the vectors to the GPU. So next thing, I think that's it for our spline. Awesome. All right, next, go to the top. So we're going to add pspline as a global variable. So here we used to be a local, now it's going to be global. So this way we can access it outside. We can access it so we don't lose the reference to it. We build our cube that we're animating. We push it to our scene. We've done this probably a dozen times already. And now we're going to go into our unrender function. So we're going to have 2 quick variables that we're just throwing in there just so we can quickly do some animations. What's I? I is just our current place that we're incrementing on the spline, so it's going to be a number between 0 and 1. And inc2 is, I'm just going to increment by that. So right now it's at inc2. If I want, I can do 0, 0, 1. Click save. You see how fast it's going. If I refresh it, it should be going slow. You can probably see how slow, you can probably see how it moves. Let's change that to there you go. You kind of see it moving now. Eventually it'll move away from the grid. So yeah, so that determines how fast the cube moves. So it's increment. And we're going to use our delta time to say, this is how fast we're going. For every second, we're going to go this fast. And then we just add to it. So now we know what increment or what position or what time. This actually should be t instead of I. But now that we know at what time if you make it easier to understand, I guess you can look at the entire curve as a timeline. Do I still have that huge ass thing? No. I hate now that the direction vectors are huge. I guess I just never saved it. There you go. You can look at our spline as a timeline, all right? And our timeline has a start and has a finish, and at any point in the timeline, we want to, if we want to get a point on the timeline, we have to give it like a year, or if you, let me explain it like that. So this is a timeline, and this is a timeline of 1 year, and so it's 0 to 1, and what we're just going to say is what day in that year do we want to know the position. So if we say January it's 1st or January 30th, maybe it's around here. If it's June something, it's around here. So that's what we're kind of doing. So yeah, you know what? I kind of lost track of what I was doing. I'm just winging this. So yeah, that's right. I was over here. So we're just getting the position of that timeline. And when we get asked the position of that timeline, we're going to get its x and y and z points. So once we know its x and y z position, which we're saving here, we just copy it into a G model. And then fungi render will then render at that position. And this point right here, we're just going back and forth. So this, if we go over 1 or equal to 1, we're going to flip our increment. And if our increment's 0.2, we times it by -1, it becomes -0.2. And and then we put the increment down to 0. So this way, next time around, we'll be under 1. So this if statement won't happen, because if I don't do that, sometimes when it reaches the end, it gets stuck there. So this makes sure it doesn't get stuck. And it's the same thing in reverse. So if we reach the beginning of the line and we're trying to go past it, we flip the increment and we set it back to 0. So that is that. So this is what we've seen. So now let's get this to animate properly. We want the red face to be looking in the direction that these direction vectors are pointing. So the first thing we got to do is you got to go back to fungi core, and this is our quaternion class. Just double checking, yes, it's quaternion class. And we're going to use look rotate. It took me a long time to find a pretty good look rotate math thing, and I found one at this site, Pastebin. Someone posted it. They're really, like I said, this is like probably the best one I found that actually works really well. It's written in C#. Does it have a comment of who did this? I guess Quanterm. Thank you, Quanterm, for a really great equation. It works really, really well. So thanks to him, we have that. But there is one problem with it, is that if the direction we're looking at is the same direction of what up is, it kind of messes up a little bit and it starts to roll a little. It starts to rolling. So as long as we're not going straight up perfectly, we won't be rolling. But I tried finding a bunch of equations, or try a bunch of algorithms, and I just couldn't find anything. So this was the best one I could find. That I ported it to JavaScript, so it's through C#. And this part is a little different than the original. Here's the original. Because, like I said, I looked at a lot of different ones, and I found one that had the exact same, or almost the exact same style. Like it was almost, the certain things were off. There was I think because everything was off, but I think because the matrix was a column major instead of row major, so it didn't work for me in the beginning. And then once I realized everything was flipped backwards, that was a problem. I tried to fix it, and I got it working, but it was still not 100% perfect. Like this one is really the best one, other than that one little issue about rolling if these two are exactly equal. The whole point of the look rotate is that we want to point our cube in the right direction that we're looking, but at the same time we want our up direction to kind of be up. So this way it doesn't start rolling randomly. So that's what look rotate is about, is to get us in that direction while kind of keeping up as much as we possibly can, which is where the bug comes in, because if the direction is up, it doesn't know how to handle it. Like I think they might mention somewhere that it needs an if statement, but it was never included. So yeah, like I said, I found another example, and I just like the style of how it was written. To me, it's a lot cleaner compared to the way this is written. And I don't like it uses, num8 and num4, 9, num7. It confuses me a little bit and what is going on. This one's a lot cleaner. It's neater, and at the same time, it makes sense the way it's you got your W, X, Y, Z. Everything's in an order for a specific reason, but it kind of shows you. It makes it clear what's kind of going on here, even though I don't understand the math that well. What I do understand is that this whole thing is a matrix. So what's this thing is what all this right here is doing is calculating the new up axis. This creates the new up direction based on the other rotation, and this one creates our left axis. So we know what direction we want to go, so we want to know what the left looks like and what the up looks like based on those two. So this is kind of creating our 3-directional vectors. And this down here kind of just converts those 3-directional vectors into basically a matrix, and then that rotation matrix is then applied to kind of convert it into a contorian. So that's, ooh, wait a minute. Buggy. I see a bug there. That shouldn't be there. Like I said, I was rewriting this. Buggy. They should be 6. Oh my god. I love when I catch a bug while I'm recording a video. So yeah, this whole thing really converts the matrix into a contorian. That's what all this is. This is what I'll do. Like I said, even though I don't understand the math, I kind of know what's happening because I've spent a lot of time researching this. So now that we have our look rotation function, hope I didn't break this in the process. Back in our render function, we're going to get our direction. It's at the same time on our timeline, which returns our direction vectors. Oops, I'm going to break this out today, aren't I? Now we're going to do our contorian look rotation. This is the direction we're looking. We want to point up, and up is just the Y at 1. And then we want to save the results into our model.rotation, which is a contorian. So this way, when render happens, it creates our view matrix or model matrix that has our rotation and position all set up to go. So as long as if I didn't break anything, get rid of this, do a refresh. Now you can see that our cube now points in the exact direction that the directional vectors. So there you go. Ta-da. Dee-dee. Now this is just a single Bezier curve. Don't forget, in the previous lesson or 2 lessons ago, we made a spline out of it. So let's do 3 curves. We'll define our spline. Now we got all these crazy points. Whoa. Now we can do some fun stuff now. Whoa. All right. Move our point that way. Define some weird ass curves. Essentially, if you think about it, what we have now here is a roller coaster. We now are building basically a roller coaster track in real time, and we basically see our little roller coaster cart going through it. And even though I want to change the speed, if I do that, I have to refresh, and then I'll lose my track. So there you go. That's too tight. I don't like how tight that is. So yeah, let's make that way. There you go. Now think about it. If we take that cube, no, we're doing the rotation and we're doing doing the rotation, and we're doing the position, and we apply that to the camera. Now, I'm not doing that, but can I do that? I don't know. I don't feel like crashing and burning. So yeah, and on top of that, I lose my track if I refresh. So, but that's something you guys can do. Just try apply it to the camera and see, going up and down, basically in a sine wave. But yeah, here you go. We're doing splines and we're animating on the spline. So you go, and I love the fact that we can modify this in real time. It's all modifying in real time. The thing is animating right along with it. We're able to rotate. Like the idea that we can just zoom in, because I have a really bad mouse with a bad scroll wheel. It's all jaggedy. When I use my tablet with mouse gestures, it's so much smoother. So yeah, I can follow. It's like, yeah. Whoa, where'd it go? There's our See, I'm wasting a lot of time just playing with this. I think you guys too probably would end up just sitting there playing, seeing what you guys can do with this. So probably this is only 30 minutes so far, or maybe just 20. So this is probably a pretty short video. So there you go. We're going through a lot. In the next lesson, we're going to continue on with Bezier curves. But the next one is going to be probably my most favorite thing that I've been waiting to do for over a year. I really got into Bezier curves, I think, about a year ago, or over a year ago, when I saw a Unity kind of a demo, and the guy was able to do exactly this: draw, basically build a spline in Unity, and have, can't remember if he was able to have, he had a cube rotate on it. But what he did with these splines is that instead of animating, he actually built procedural roads. So what the next lesson we're going to do is I'm going to take a rectangle and then apply the rectangle at a bunch of increments on the spline. So every time there's a turn, like you kind of see. Let's see if I can zoom in. Oh, that's right. I forgot I got keyboard functionality up in here now. So yeah, like you have one point, another point, another point, and a time. Instead of just putting basically a dot and doing instead of just doing that, like just putting a point, or drawing lines at different points, I'm gonna put like a 2D mesh. So like I said, I'm gonna put a rectangle there. I'm gonna put a rectangle there. Put a rectangle there. Put a rectangle. Basically put a rectangle at every single spot. Then I'm probably going to link all the dots together with maybe a triangle strip, which then generates a mesh following that spline. So like right now, it's really cool that we can have these dynamic real-time lines being created in real time. Now, can you imagine we can have an entire mesh, like an entire road, being generated on the fly every time you move these little points around? And that's what the demo did in Unity. And like I said, I saw it over a year ago. I fell in love with it. I felt like I was a moron because I was not smart enough to do it or understand it. And look at us now. Look at me. Look at you. Look at all of us now. Now we're almost there. And it's kind of great because it's going to be video 30. So I'm surprised I'm actually at video 30 already. Normally when I do things, I kind of just at some point move on to something else, but yeah, we're reaching the point where I'm really having fun with this, because now we're doing more complex things, because just dealing with textures and cubes aren't fun. But if you're making a cube animate on a spline editor tool that you built from scratch, now that's freaking great. So I think I'm babbling on too much. It's like I probably have to end up repeating myself for the next lesson when we're actually doing the extruding the mesh on a curve. But that's going to be my most favorite video to make, or I guess the most favorite thing I'm going to prototype to make for a video. I've been reading a lot about that lately, and the notion is everything we have for this lesson is there, because since we already have the look matrix, the look rotation, that already gives us a rotation matrix. Remember I said it gives us a rotation matrix, and so we can just use that rotation matrix to do basically just a matrix multiplication on the vertices of that rectangle. So this way, technically I should have all the pieces I need to do it right now. So I don't know. If I had a lot of viewers, maybe I would stay up one night and do a Twitch thing and actually try to hammer it out on my own in front of everyone. But I don't. And there's no point in that. Besides, my Wi-Fi is kind of sucky lately, so I probably won't stream very well. So yeah, let me just. Yeah, I'm wasting so much time just playing with this. Sorry, and talking about the next lesson. So, like, subscribe. I hope you're having fun. This is great stuff. I know there's a couple of things. I know a viewer asked to do wireframes. I have an idea of what to do for wireframes. When I'm done with dealing with splines, I'm going to go into spheres, and I might do one of the spheres. I'm going to do a simple polar sphere, and I was thinking, since that's kind of a simple thing to do, I already have that done like months ago. And maybe I'll extend that lesson to include, here's a sphere and let's make it a wireframe. So if you're watching, that's where I'm gonna I'm gonna try to stick wireframes. After we're done with splines, I have 2 more lessons to do with splines. Then I'm gonna jump into spheres. There's like 4 different spheres I want to experiment with, and there's a page that actually shows you all the pseudocode on how to generate all the spheres. Polar spheres are easy. The other ones are more complicated. Those I don't know how to do, but polar spheres are pretty easy to do. They're just grids, but in a spherical form. Yeah, that's it. So that's really the direction we're going into the next couple lessons, and yeah, that's it. I guess that's it. See you guys next time. Bye bye.